and welcome to Math Blossoms, where growing in mathematics is natural. Today's lesson topic is complementary and adjacent angles. Let's get prepared by getting our pencil ready with an eraser, some paper, and a calculator is optional for self-checking. And also the straight edge might be useful, but not required. Don't forget to pause the video from time to time to answer the practice questions, and rewind the video if you need to review anything before answering any of the questions. Okay, so before we do our vocabulary, I'm Miss G, and we're going to start off our lesson today by doing some deep breathing. So let's breathe in our nose and out our mouth. We're going to hold it in for a count of 3. As we do so, we're going to release any kind of thoughts that might be, distracting us from our math learning today. So let's go ahead and breathe in our nose. Hold it for 1, 2, 3, then breathe out. Breathe in our nose. Hold it for 1, 2, 3, breathe out. Okay, breathe in. 1, 2, 3, then breathe out. All right, good. And if you need to take additional breaths along the way, just pause the video, take a couple of deep breaths, try to center yourself and clear out anything that might be distracting you from today's lesson. Okay, let's go ahead and look at this quote first. We have, "A flower does not think about competing with the flower next to it. It just blooms." And I like this quote because I often see students comparing themselves with other students and competing. And, if one person gets a problem correct and then the other person didn't get it correct right away, sometimes, I see people making fun of each other, and I just feel like, that's such an unhealthy attitude because we're all on the same planet. So we don't want anybody to not succeed. We just want people to be successful and for people to be happy. So just think about that the next time someone, you're comparing yourself to someone that you think is better. Maybe there's some things about you that they like, and they might be admiring you about. So just think about that. Okay, so theorem is one of those math laws or math truths that we know and we can prove. And the one theorem we're going to talk about, we're actually going to talk about 2 in this unit, but the first one we're going to talk about is the triangle sum theorem, which states that for every triangle, all of the angles within the triangle added together must equal 180 degrees. You can almost think of a triangle as like a line, a 180-degree line that has been bent on both sides to create that triangle. Okay, so vertical angles are those angles that are on a crisscross opposite each other, and they are congruent. Supplementary angles are those angles that add up to 180 degrees. Complementary angles, which is in our video today, is going to be 2 angles that add up to 90 degrees, or a right angle. And a right triangle is a triangle that includes a right angle inside of it. Adjacent angles are those angles that are right beside each other, sharing a vertex point and a side. Okay, all of the others we're going to discuss more in the parallel lines and transversals video. Exterior means all the angles outside of something. Interior means all the angles inside of something. That could be a triangle, or it could be parallel lines. If it's between 2 parallel lines, that could be interior. But if it's outside the 2 parallel lines, it could be exterior. So all of these we'll talk about more on the parallel lines and transversals. And you will know what these mean after watching that video. All right, lesson essential questions for today. We have define the adjacent angles, define complementary angles, and explain how to use complementary angle relationships to solve for a missing angle. Okay, so what are adjacent angles? Well, adjacent angles are 2 angles that share a common side and a common vertex, And sometimes adjacent angles are supplementary, sometimes they're complementary. They can never be vertical angles, though. Vertical angles are never adjacent to one another. So here's a good example on the right here where you have, this angle X and this angle Y. Well, they're not sharing the same vertex point. Y has a different vertex point than X. They're also not sharing a side. But here, the C and D, they are sharing this side. You can kind of think of adjacent as like neighbors. They're right next to each other and they share this, like, it's almost like a fence in between the 2 yards. And they also share this common vertex point. A vertex point is the corner of the angle, basically, that point right there. Here we have another complementary, or excuse me, adjacent angle relationship. Angle ABD here is going to be adjacent to angle DBC. And remember, there are several different ways you can name an angle. You could say, oh, it's angle B. Well, if you're talking about angle B, you could be talking about this angle or this angle, right? So if you have a situation like this, always call it by all 3 points of the angle, and that way you'll know. And the B, the vertex, is always the center letter. So like angle ABD, notice the B is in the middle. That's because that is the vertex. So the vertex always goes in the middle when you're naming that. And so here's an example of some supplementary angles. This one's adjacent to one another, sharing that side and that vertex point, and these two are not adjacent to one another. Okay, supplementary angles are also called linear pairs, and hopefully you've watched that video before watching this one, but if you didn't, we're going to review it real quick. A supplementary angle relationship or a linear pair is when the measure of 2 angles add up to 180. The angles could be adjacent or not. So here again, we've got these 2 supplementary angles, 128 plus 52, that's going to give us 180. But they are adjacent to one another. This one here is not a supplementary angle. This one's a complementary angle because complementary angles add up to 90. So 52 plus 38, that's going to give me a 90. And there's that right angle right there. Again, these are adjacent complementary angles and these are adjacent supplementary angles. The straight angle is formed when supplementary angles are placed adjacent to one another, creating a line. So notice how this angle and this angle makes this bottom line here. And here's just another example of supplementary that adds up to 180, where these are adjacent, sharing that fence or that ray there. In geometry, we call that a ray. And that vertex point. Also, over here we have 2 that are not adjacent, but also supplementary. Okay, so vertical angles, again, this is in the supplementary angle and vertical angle video. So if you haven't checked that out, go ahead and check that out after this one. A vertical angle relationship is when 2 opposite angles form across from each other from 2 intersecting lines. Vertical angles are not adjacent, so they will not be adjacent. X cannot be adjacent to this X over here. Yes, they do share the vertex point, but they do not share a side. They do not share, like X is sharing a side with Y, so X and Y would be adjacent, but X and X are not. But these are vertical, and Y is also vertical to Y here because they are exactly opposite each other on this crisscross. Vertical angles are congruent, which means their angle measurements are equal to one another. So again, X and Y here looks like it could be a supplementary pair because it's creating this line here. But X and X is not a supplementary pair. They're just going to be equal to one another. Y and Y is also going to be congruent or equal to one another because they're vertical. All right, so parallel lines and transversals. Again, we're going to watch the video on that sometime after this video. So and this is just to show you what that looks like when you have those 2 parallel lines and a transversal slicing through it. Lines never intersect each other, no matter how far they are extended. Those are called parallel lines. So here we have line CD here and AB. Those are parallel. Down here it says line AB, parallel, that's the little parallel symbol, line CD, okay? This line M and N, they're both parallel, so M is parallel to N. Then we have this line 1 and this line 2. They're also parallel to one another. And you can tell that from those little arrows there, those little black arrows. That's signifying that those two lines are parallel. Now, the lines slicing through the parallel lines, those are called transversals, okay? So they usually cut through, it could be more than two parallel lines. Sometimes it'll cut through, several. But for this purpose, we're just going to use mainly just one slice a lot of times, just to show you guys what the angle relationships that form are when this happens. And that's going to be in the parallel lines and transversals video. Okay, complementary angles. Now, two angles that form a 90-degree right angle when added together are called complementary angles. Sometimes complementary angles are adjacent and sometimes they're not. So here we have two angles here. They form this right angle here. 70 plus 20 is going to be a 90. Okay. We have 45 and 45 again. Those two added together makes a 90. So those are complementary. Those are complementary. These are adjacent here. These two, A and B, are adjacent. But C and D, these are not adjacent. Notice they're not sharing the same vertex point and they don't share a side. But they're still complementary because they still add up to 90. 53 plus 37 is also adding up to 90. So not adjacent, adjacent, but they're all complementary. Okay. Here we have an adjacent complementary angle pair and a non-adjacent complementary angle pair. And then here's some adjacent angle pair as well. Okay, so let's practice this. Find the measure of X, okay? So here we have a right angle on the side of this line. So I know when I have a straight line that that's called a straight angle, and this bottom line must be 180 degrees because the straight line, that's the angle that it forms. When it's just laying flat like that, it's 180, okay? So when I have this 90 degrees on the left side, creating that angle, then the other side has to also be 90 degrees because 90 plus 90 makes this whole 180, okay? So we know that this angle and this angle are going to be complementary because they're going to have to add up to 90. So here's how you do that. Take the measure of angle 1, add it to the measure of angle 2, and make it equal to 90. So our first angle was 73. We're going to add it to X, which is the second angle, and make it equal to 90. Subtract your 73 from both sides, and X is going to be 17. So that's your answer for this angle here. Okay. Now find, and of course, if you wanted to check yourself, 73 plus 17 is 90. Okay. Now we're trying to find the measure of 2y. So that's this little angle here. And since it's being separated by this line, we know that, let me use my pointer here so you can see what I'm doing, or my pen. So we know that this one has to be a right angle because it's 90, which means this one also has to be a right angle. Okay, which means the 50 and the 2y added together have to equal 90 because 90 plus 90 makes this straight line here, which is 180 degrees. All straight lines have 180 degrees. So let me erase that so you can still see it. So I know that 2y plus 50 has to equal 90 because 90 plus 90 must make this line, okay? And if it helps, I tell students sometimes if it helps to like take a piece of paper or something and cover up the part you don't need, sometimes that helps because then you don't really need this side at all. But it may not help you, but it might. So if it's confusing you, cover that bit up and just look at those particular angles. So the measure of angle 1 and the measure of angle 2 added together equals 90 because this is complementary. And the first angle was 50, the second angle was 2y. We have a two-step equation, so we need to subtract our 50 from both sides. We're left with 2y equaling 40. And then we divide that by 2 to get rid of that 2y. And 2 divided by 2 is 1y, and then 40 divided by 2 is 20. So y is equal to 20. But we don't want to find the measure of y. We're trying to find the measure of 2 times y. So we've got to take that 20 and we've got to multiply it times 2 to get our actual measurement for this second angle 2y. And 2y is going to be equal to 40, which makes sense because 50 plus 40 does equal the 90. Okay, this one here, this was a more complex version. We have 2 parallel lines. It's got a transversal going through it this way, and then it's got a transversal going through it this way. Okay, so again, we have a straight line and a 90-degree angle right here. And so the other side of that here has to also be 90. So this z plus 5 and this 30 has to all equal 90 because this whole line is 180, right? So when we set that up, we would do the measure of angle 1 plus the measure of angle 2 equals 90. So that's z plus 5 is our first angle plus 30, which is our second angle, equals 90. We're going to combine our like terms, the 30 and the 5 together, and then we're going to subtract 35 from both sides to undo that addition, and we end up with z equaling 55. Now that we know what z is, we can plug it into this angle. It's z plus 5, and you could probably do that in your head, 55 plus 5. It's just going to be 60 degrees. And it makes sense because 30 degrees plus all of the 60 degrees is going to end up being 90. Okay, now we're finding the measure of angle A minus 13. And we have a right angle here, so we know they're complementary. So we're going to add those 2 angles together. The first is the A minus 13. The second one, I'm making my 53. And then we combine these like terms. So 53 combined with a minus 13 or a negative 13 gives us a 40. Okay. So A plus 40 is 90. Subtract your 90 from both sides. A is going to be 50. And then when we take the A and subtract 13 from it, we end up with 37. And so we know we're correct because 37 plus 53 here is going to give us that 90-degree angle. So setting up an equation by adding the 2 complementary angles together and making them equal to 90, then solving for the variable. Substitute the variable back into the unknown angle if necessary. And that's what we're doing down here when we substitute it. A minus 13, we're substituting that 50 for the A, and then we're just finding out what the full angle would be. Okay, so it's your turn to try and grow a blossom. So go ahead and pause, and I'm going to count to 3. Are the angles adjacent? And explain your answer. So go ahead and pause. 1, 2, 3. Yes, angles X and Y here are adjacent because they share a common vertex point, which is this point, and a common side, which is this side here. They are also supplementary. For the second one, these are not adjacent because A and B do not share they share the same vertex point, which is this point here, but they don't share a side. Notice B and, let me change colors because it's kind of hard to see my pen when I'm not, let me change it to blue. Okay, so it's kind of hard to see this, but these are the 2 sides for B, and then these are the 2 sides for A, and they're not, next to each other. So they're different. These are vertical angles, which means these are congruent. Okay, let's try to grow a second blossom. Use complementary angle relationships to determine the measure of angles D and Y. Oops, hang on one second. Okay, sorry about that. This should say D and C, okay? So you're finding this D angle and this C angle. So go ahead and pause. 1, 2, 3. All right, so here we have 30 and D, and we know that it's a right angle. So we're going to add those together, make them equal to 90, subtract our 30 from both sides. D is 60. A lot of you probably did that one in your head, but remember, sometimes you're asked to, show your work and show how you came up with that answer. So this is a way to do that mathematically, is to set up that equation. For number 2, or the second one, Add the two angles together, make them equal to 90, subtract your 23 from both sides, and you end up with C equaling 67. Okay, let's try to grow a third blossom. Use complementary angle relationships to find M this time. Pause. 1, 2, 3. Okay, the measure of angle 1 plus the measure of angle 2. M minus 4 was our first angle, and then the second angle was this 39. All of that has to equal 90 because on the opposite side there's 90. And we know 90 plus all of this 90 has to equal this line, right? So we subtract our 35 from both sides, and X is going to equal 55. Hang on, there's an error. Alrighty, so it's M equals 55. I'm not sure why I changed that variable to X, but for some reason I did. And notice here that they didn't ask you to find the measure of this whole angle, M minus 4. They only asked you to find M. So you can stop here. I mean, normally if they're asking you for the whole angle, you would take that 55 and subtract 4 from it. But they're only asking you to find M this time. On the other side, the first angle plus the second angle, this is M plus 17 and 25. All that has to equal 90 for it to be complementary. And then we subtract our 42 from both sides to solve that equation. There's another X, hang on. All right, so M should be 48 on this one. Okay, now we're going to do a fourth blossom. Use complementary angle relationships to find X. So go ahead and pause. 1, 2, 3. All right, so we know that this left-hand side is 90 here. And since this is a line, we know that this whole right-hand side must be 90 as well, because 90 plus 90 is 180. So our complementary relationship is between X plus 24, that angle, and then the 14. So we set those two up, add them together, make them equal to 90. Combine your like terms, your 24 and your 14, making a 38. Subtract that 38 from both sides, and you end up with X equaling 52. Again, they're just asking us to find the X, not to go ahead and plug it back in to find the actual angle measurement. So we don't need to do that extra step. Okay, the second one, first angle, oh goodness gracious. First measure plus the second measure, the second angle equaling 90. Now X plus 7 plus 26 equals 90. Combine your like terms, the 17 and the 26 together gets you a 43. And then when you subtract the 43 from both sides, X is going to be 47. And again, we didn't need to add it back to the 17 or anything because they just wanted to know what X was. Okay, great. So now let's pause and try to answer some of these essential questions. So can you describe or write down in your own words, what is an adjacent angle? Pause. An adjacent angle is an adjacent angle relationship is when two angles share the same vertex point and also share a common side. They're like neighbor angles. Okay, pause and answer this essential question. Define what is a complementary angle. Okay, a complementary angle relationship is when the measure of two angles added together equal 90 degrees or a right angle. Okay, and the third, answer the essential question. Explain how to use complementary angle relationships to solve for a missing angle. Pause. Okay, so set up an equation by adding the two complementary angles together and make them equal to 90, then solve for the variable. Substitute the variable back into the unknown angle if necessary. Great job! So let's do our quick vocabulary review, and this little otter is just adorable. It's one of my favorites. Okay, so theorem is like a math law. It's like it's something that has been proven to be true over and over and over again. Triangle sum theorem is when we add all three angles in a triangle together and they always equal up to 180 degrees. Vertical angles are those angles that are across from each other on a crisscross. They're on opposite sides of the crisscross from each other. They're also congruent to one another. Supplementary angles are two angles that add up to 180 degrees or a straight angle. Complementary angles are two angles that add up to 90 degrees or a right angle. Right triangles are those kinds of triangles that have one 90-degree angle inside of it. Adjacent angles are those angles that share a common vertex point and also a common side, and they're right next to each other, sort of like neighbors. Exterior angles are angles outside of something, and then interior angles are angles inside of something. And we'll go over these in the parallel lines and transversals video. Parallel lines are those lines that never cross, and transversals are those lines that slice through the parallel lines. Okay, great job. A bouquet of math blossoms have opened up in your mind today. So to further improve your math language skills, remember to practice by doing your assignments at school and study 10 minutes each day at least. If you're doing more, that's great. If you really think you need the extra practice, ask your teacher for some extra practice work. If if you've mastered what they've given you in class, maybe you might want to do some more challenging problems. So always, if you think you need more practice, ask for more help. Ask your study buddy or a family member or anyone to help you if you get stuck, and then learn from your mistakes. Don't be afraid to make them, and don't feel ashamed to make them, because we all do, and it's just part of learning math. But always try and do your best, and you'll come out all right. I'm Miss G. Thank you for watching this video on complementary angle relationships and adjacent angle relationships. The next video in this series you should watch is the triangle sum theorem, to remind yourself how that triangle sum theorem works when we create equations finding unknown angles, or the exterior angle theorem. So one of those you need to do for the next video in this series. Thank you for watching Math Blossoms once again, and now it's time for me to say it was lovely teaching you math today.